Welcome to the deep dive. It is really great to have you with us today.
Yeah, thanks for having me. Excited to be here.
We have a seriously exciting mission lined up for you. We're looking at a stack of incredibly fascinating sources today.
Lots of ground to cover.
Right. Academic papers fresh off our SIGs,
Yeah.
corporate tech blogs, and even some internal documentation from a few cutting-edge startups. We're taking all of this to uncover what is shaping up to be a massive fundamental shift in artificial intelligence.
It really is.
We are talking about something called agentic storage. If you want the mental shortcut, just imagine a smart hard drive built specifically for AI.
It's a profound shift, honestly. We're looking at a transition that completely changes how we interact with these systems, moving from, isolated one-off chats to actual persistent relationships.
And to set this up, let me ask you a question. Have you ever had one of those brilliant, highly nuanced conversations with an AI?
Oh, absolutely.
Right. You spend 20 minutes giving it all this context, you're brainstorming, you're making real progress.
Yeah.
And then you ask a follow-up question maybe 5 minutes later,
Yeah.
and it has completely forgotten everything you just talked about.
It's the worst.
It is. It's like the AI has digital Alzheimer's. It's incredibly frustrating to deal with that lack of continuity.
It is the defining bottleneck of the current AI experience, but that is exactly what we're exploring today.
Exactly.
We are moving past this era of finite, fragmented memory. What our sources show is that we're stepping into a 2026 reality where the AI actually acts as the owner of its own memory.
The owner.
Right. It's autonomously storing, organizing, updating, and retrieving information on its own.
To give you a roadmap of how we're going to tackle this, we'll break down the two main faces of this agentic storage revolution. First, we'll look at memory for the agent, how it manages its own internal thoughts.
Right.
And second, we'll look at storage managed by the agent, how it can actually take control of our external files and our digital lives.
It's a big leap. Huge leap. But before we get to the solutions, we need to acknowledge the problem we're solving. We all know the headache of LLM statelessness. But why is it so stubborn to fix?
Well, what's fascinating here is that despite all the algorithmic advancements we've seen, LLMs still suffer from three historical limitations.
3 Achilles heels.
Exactly.
Right.
The first, as you mentioned, is statelessness. By design, these models don't hold on to a continuous state of being.
Right.
Every single time you start a new conversation, the AI is essentially waking up from a coma. It starts completely from zero.
But we've tried slapping massive context windows on it to fix that, right? I mean, you can feed an entire book into an AI prompt today.
You can, but that space is still finite. That's the second limitation.
Okay.
More importantly, processing millions of tokens for every single interaction is incredibly expensive. It's computationally heavy.
Yeah, that makes sense.
Feeding your entire operational history into a prompt just to ask a simple scheduling question is not a sustainable way to maintain a long-term relationship with an AI. No, you can't just keep pasting your entire life story into the prompt box every time you want to say hello.
Yeah.
The compute cost alone would bankrupt a small company.
And that leads to the third limitation. There's no true long-term memory.
Right.
Current AIs do not autonomously learn or evolve from their experiences over time. When you and I have a conversation, my brain takes that new information, integrates it, and it subtly changes how I view the world tomorrow.
It sticks with you.
Exactly. A standard LLM does not consolidate memories like that.
To put this in perspective for you listening, think about it like having an incredibly brilliant executive assistant who literally dies every single time you close the app on your phone.
That's a great way to put it.
Because of this, you get hallucinations, you
Yeah.
get a massive loss of context in any kind of long, multi-step workflow.
Yeah.
Now, we've relied on workarounds like RAG, retrieval augmented generation, to fetch external documents, but RAG doesn't learn.
No, it just
Oh.
searches.
Right, it just searches. Agentic storage is different. Okay, let's unpack this. Let's look at the first solution, an AI that manages its own memory much closer to how a human brain works.
This brings us to a groundbreaking 2025 paper titled AMEM, which stands for Agentic Memory for LLM Agents.
Amen.
Yeah, this was published on arXiv under the identifier 2502.12110. The authors of this paper did something incredibly clever. They looked to history, specifically to the Zettelkasten method.
The Zettelkasten method. For anyone who hasn't gone down a productivity rabbit hole recently, that's the system of linked notes used by prolific German academics to organize their research.
It translates to slipbox.
Slipbox, right.
It's a method of taking small atomic ideas on index cards and physically linking them together together through referencing, creating this massive web of interconnected knowledge.
That's like an analog hyperlinking system.
Precisely. And the authors of the AMM paper took that exact philosophy and adapted it into an agentic format for AI.
Okay, so instead of a massive text file, how is the AI actually storing these Zettelkasten notes so it can find them later?
In the AMM system, every time the AI gets a new memory, it creates an atomic note.
Okay.
And that note isn't just plain text. It comes complete with a contextual description, specific keywords, tags, mathematical embeddings, and automatic links to other relevant notes in its database.
Wow.
But the crucial difference here is agency. The agent itself dynamically decides what notes to connect together.
No way.
And it even updates its old notes when new information arrives.
Wait, so it actually edits its past knowledge?
Yes. It is mimicking human learning. When we learn a new fact that contradicts or maybe adds nuance to something we learned 5 years ago, our brain updates the old memory.
Right, you adjust your worldview.
Exactly. The AMM framework allows the LLM to do exactly that. It's a dynamic, self-maintaining web of knowledge.
Here's where it gets really interesting. The researchers actually provided visual proof of this in the paper using TSNE visualizations.
That part was wild.
It really was. For context, TSNE is a technique used to map high-dimensional data into a 2D space so we can actually look at it on a screen. And when you look at the TSNE visualizations of the AI's memories over time, you see them organizing into these coherent clusters.
Which is a massive breakthrough.
It really is. Because the takeaway here isn't just that the AI organizes data well. It's that by using spatial memory clustering, the AI is moving from being a mere calculator of text to an entity that builds a personalized worldview based on your interactions.
Yes.
It's forming actual concepts.
And we have hard data from the AMM paper to back up how effective this worldview is.
Let's hear it.
They tested this system using the Locomo benchmark, which evaluates long-term conversations spanning up to 35 different sessions.
That's a lot of context to hold.
It is. And compared to existing baselines like MemGPT or Memory Bank, the AMM system improved F1 scores by 8 to 35%.
Let's translate that for a second. An 8 to 35% jump in F1 essentially means the AI stops hallucinating past events. It actually recalls what you did with high accuracy.
Exactly. And the BLEU scores, which evaluate the quality of the generated text based on the historical context, improved by up to 192%.
192%, which means the AI sounded significantly more fluent and human because it wasn't losing the thread of the conversation halfway through.
Yep.
But I have to ask, does that token reduction hold up? You mentioned earlier that huge context windows are just too expensive.
It absolutely holds up. It achieves all of this at a fraction of the computational cost.
Really?
Yeah. The system only uses about 1,200 tokens per operation. When you compare that to the competitors in the space, that is an 85 to 93% reduction in token usage.
So you're getting an infinitely smarter AI that actually remembers you, and it costs pennies on the dollar to run.
And the research didn't stop in 2025. The sources also point us to a second paper from January 2026 called AgeMem, found at RTIF 2601.01885.
AgeMem.
This framework takes the concept a step further by introducing reinforcement learning.
Which makes sense, because if I'm chatting with an AI over 6 months, at what point does it decide a memory is long-term versus something it can just forget? How does it make that choice?
That's exactly the problem AgeMem solves. The system trains the agent to manage its short-term and long-term memory simultaneously within a single framework using a reward function.
Okay.
The agent learns to autonomously ask itself critical questions in real time. It evaluates, do I need to save this detail to long-term memory? Should I just summarize the current context? Or should I filter out this piece of information because it's irrelevant?
It's acting as its own editor.
It is. Agentic storage uses reinforcement learning to penalize the AI if it retrieves irrelevant data that clutters the context window, forcing it to become a better librarian of its own knowledge over time.
It's brilliant.
AgeMem showed a 4 to 8 percentage point boost over previous top baselines just by optimizing those decisions, producing much higher quality memory while continuing to lower the overall token consumption.
So if AMEM and AgeMem are about giving the AI its own internal hippocampus, what happens when we give it the keys to our external world?
That's the next frontier.
Our hard drives, our cloud servers. Let's shift to the second phase storage managed by agents.
This is where we see the rise of the IT admin AI. Instead of just managing its internal memory states, the agent is granted the ability to interact with and manage physical or cloud-based storage systems.
I want to break down how this actually works, because it sounds like we're just handing the steering wheel over to the machine.
It does sound like that.
Our sources mentioned a blog post published by Pure Storage in February of 2026. They detailed an integration using the Model Context Protocol, or MCP.
MCP is vital here. It's an open protocol that essentially allows any LLM to speak in natural language directly with on-premise storage systems.
So no more manual coding for every command.
Exactly. It translates intent into secure, executable infrastructure commands.
Okay, picture this. You're managing a massive corporate server farm. Normally, you'd be typing complex commands into a terminal, pulling your hair out.
Right.
But with this pure storage setup, you tell your AI in plain English, show me all the buckets of the two arrays, sort them by space used, and create a graph of the last 7 days.
Just like you're talking to a coworker.
Exactly. And the AI parses that prompt, queries the servers via MCP, aggregates all the raw data, and executes the final command perfectly. The user never touches a command line interface.
It completely removes the barrier between human intent and complex infrastructure. And this isn't just software talking to servers from afar.
Right.
IBM is taking it a step further with IBM Flash System.ai. They are baking these AI agents directly into the hardware itself.
Baked right into the physical drives.
Yeah.
Think about the panic of a 3 a.m. server crash or a sudden ransomware alert. Human reaction time is inherently flawed.
Very flawed. By living at the hardware level, the agentic storage can autonomously monitor the system to detect those ransomware attacks the microsecond they begin.
The microsecond.
It can isolate the compromised data, dynamically optimize data compression on the fly to save space, and automatically migrate data between different storage tiers without a human ever waking up to intervene.
It is like having a tiny, brilliant IT department living inside the metal of your servers. But this isn't strictly an enterprise play either. The startup ecosystem is all over this.
Oh, yeah.
The sources highlight Nalime AI, which bills itself as the world's first true agentic storage system. What they've done is give your personal AI agent a complete operating system of files.
It bridges the gap between conversational memory and traditional file storage. It's not just a chat window anymore, it's a persistent workspace.
There is a demo they put on YouTube that really illustrates the mechanics of this. In the video, the user tells the Nalime agent, create an Excel file with NYC job offers, save it in the Job Hub folder, update it every week, and highlight the low-paying jobs in red.
Notice the layers of execution required there.
Exactly. The agent has to parse the prompt, navigate its internal file system to create the folder, write a script to scrape the internet for the data, format the spreadsheet cells based on numerical thresholds, and then schedule an autonomous cron job to repeat the task a week later. All while logging that it did this in its memory. It is acting entirely as an autonomous assistant with its very own hard drive.
If we connect this to the bigger picture, we have to acknowledge that a paradigm shift of this magnitude comes with profound architectural and systemic hurdles. It's not just a plug-and-play future.
Right, let's do a reality check. Our sources outline 5 key challenges that developers and engineers are currently wrestling with as agentic storage becomes the norm.
Let's go through them.
Let's spend some time unpacking them because they aren't trivial. The first one is privacy and security. If we have AI agents that map our lives and save data forever, who controls that data?
It's an architectural dilemma. If an agent has access to your files, your daily interactions, and is actively consolidating that into a permanent Zettelkasten memory web, who holds the encryption keys to that synthesized life map? A security breach is no longer just losing a few passwords. It is exposing the raw thought process and operational history of a user or a company.
The blast radius of a hack becomes catastrophic. You aren't just stealing data, you're stealing the context of the data.
Which brings us to the second challenge, scalability and cost. We talked earlier about how efficient the token usage is for a single query, but think about the sheer volume of data over time.
Right. If you have an agentic system dynamically linking millions upon millions of atomic notes over years of use, that graph is going to get heavy.
Very heavy. It requires highly efficient vector databases to search that spatial memory.
Okay.
If the underlying vector architecture isn't perfectly optimized, querying a memory from 3 years ago could become overwhelmingly expensive and slow, bottlenecking the entire system.
And that ties directly into the third challenge, integration complexity. Building this isn't exactly a weekend project for novice coder right now.
Not at all. Connecting the model context protocol, tuning vector databases, and implementing sophisticated reinforcement learning loops like we saw in AgeMem requires heavy technical expertise.
Yeah.
You're dealing with probabilistic models trying to execute deterministic storage commands. The infrastructure is powerful, but currently it is highly complex to stitch together reliably.
Which leads to the fourth challenge, and this one feels like the hardest to solve: systemically bias and memory evolution.
This raises an important question. What happens when the agent learns a factually incorrect piece of data?
Oh boy.
Because the system is designed to dynamically update and evolve its memories, a single piece of corrupted data can take root.
It's like Inception.
Precisely.
Yeah.
If bad data enters the AI's slip box, it will connect that bad idea to everything else it subsequently learns.
Right.
From there, the dynamic memory will continuously evolve based on that poisoned node, cascading and magnifying the error across all future reasoning.
How do you even fix that? You'd have to figure out how to do AI therapy to untangle the web and isolate the corrupted note without destroying the valid memories attached to
That's a
it.
huge undertaking.
It's a massive data integrity issue. And finally, the fifth challenge is adoption. To make agentic storage work, developers need to fundamentally change their mindset.
The industry has spent the last several years mastering the art of the static prompt. Developers are used to passing all the necessary information into the system at the exact moment of execution, keeping total control over the state.
Right.
Moving to an agentic model requires building dynamic ecosystems where you trust the agent to maintain its own state over time.
It's letting go of the steering wheel.
Yeah.
You're no longer giving the AI a fish. You're trusting it to manage the entire fishery while you sleep. That is a massive leap of faith for an engineer used to total control.
Absolutely.
So what does this all mean? Let's zoom out and look at the journey we just took.
Sounds good.
The core takeaway from all of these sources, from the AMEM and HMEM academic papers, to the hardware integrations from IBM, to the consumer tools from Nalima, is that AI is fundamentally transforming.
It is.
It's moving from being a reactive tool that waits for your command to becoming an autonomous agent with a persistent memory of its own. The future of AI isn't just about getting bigger and faster models. The future is about models becoming more persistent and more autonomous.
And the best way to truly understand this shift is to experience it. If you want to get hands-on with these concepts, there are several actionable ways to dive in.
Definitely.
You can try out Nalima AI for yourself. They offer a free starting tier to experiment with agentic file management. I also highly recommend reading the actual AMEM and HMEM papers to understand the underlying mathematics of those Zettelkasten memory structures.
Even if you just skim the abstracts, seeing how they structure an atomic note is fascinating.
And if you are a developer, try building your own agent with agentic memory. You can start by combining a routing framework like LangGraph with Chroma, which acts as a database built specifically for these AI memories.
Very cool.
Or try hooking up Pinecone with the Model Context Protocol to see how an LLM actually interacts with external storage.
Get in there and build something. There's no better way to grasp the mechanics. All right, as we wrap up this deep dive, I want to leave you with a final thought to mull over, pulling a thread directly from our source material about the future of personal AI.
This is the wild part.
The sources mention that in just a few years, because of agentic storage, an agent could remember your entire professional life. It will remember your preferences, your operational quirks, and even the nuances of your unique sense of humor.
Yeah.
But think about what that really means for you on a psychological level. If an AI autonomously organizes a decade of your triumphs, your failures, and the subtle evolution of your personality into a perfectly clustered TSNE map,
Right.
does it eventually become the perfect digital assistant? Or does it become a digital clone that remembers a version of you better than you remember yourself?
It's a fascinating and slightly haunting prospect when you consider how malleable our own human memories are compared to a permanent mathematical embedding.
It really is. Something to think about the next time you clear your cache. Thank you so much for joining us on this deep dive into the world of agentic storage.
Yeah.
We love exploring these massive shifts with you. Until next time, keep exploring, keep questioning, and we will catch you on the next one.